Okay, so we are looking at operations with rational expressions. This is a review, since it says review in all caps at the end there. We've already done some of this stuff together and we've reviewed some stuff, but before we get into rationals, we're going to make sure we review all of this because I'm not reteaching it 1,000 times. And these are expressions. So can we solve them? No, because are they equations? No, they are expressions, so you can't solve them, so don't try because you'll be making up math. All right, the first thing we're going to do is just simplify. When we simplify, I know that 4 is divisible by 2, but I do not get to reduce right there. I cannot cancel out my n squareds. That does not work. That is not legal because that would be undoing addition and subtraction with division, and that doesn't make any sense. But what I can do here is I can factor the numerator and denominator, and we're going to have to factor by grouping on both of them. So here, if I do 4 times 9, that's 36. So I need two numbers that multiply to give me 36, combined to give me 12. What would that be? 6 and 6. So 4n squared minus 6n minus 6n plus 9. All right, so then I'll go ahead and split up my denominator. 2 times negative 27 is negative 54. Now, I need two numbers that multiply to give me 27 and subtract to give me, multiply to give me 54 and subtract to give me 15. Now, when you have to think of these factors, I'm going to give you some reasoning skills here, because what most of you do is just stare at it and think that something's going to pop into your mind or appear on the paper. I don't know. You know for sure that two numbers that multiply to give you 54 are 2 and 27 because you literally just did it. Okay? However, those don't subtract to give you 15. You should know, if you know your multiplication facts, that 9 times 6 is 54. So 6 and 9 work as well, but those add to give you 15, but they don't subtract to give you 15. So those don't work. Instead of trying random numbers or just staring at it, break down what you have. Think about the factors of the numbers that you have here. This is 2 times 3. This is 3 times 3. So if I've got 2 times 3, I already have a 2. Let me use the 3. So if this is 3, I've taken 2 out of that, multiply that by 2, I get 18. 3 times 18 is 54, and guess what? That subtracts to give you 15. So manipulate the numbers you have instead of trying to start, come up with random other numbers. All right, so then down here, that gives me 2n squared minus 3n plus 18n minus 27. Okay, so then I'm going to factor the numerator by grouping. I can factor out a 2n. That leaves me with 2n minus 3. Factor out a negative 3. That leaves me with 2n minus 3. Denominator right here, I can factor out an n. That leaves me with 2n minus 3. Here I can factor out a 9. So I get plus 9. Leaves me with 2n minus 3. Right here is not where you try and reduce anything. You are not finished factoring. When you finish factoring, you will get 2n minus 3 times 2n minus 3 over n plus 9 times 2n minus 3. Now you can reduce because you will be undoing multiplication with division. I can cancel those out there, and that leaves me with 2n minus 3 over n plus 9. What questions do you have? Good? Awesome. All right, so now we're going to look at multiplying and dividing. When you are multiplying fractions, do you have to have a common denominator? No, you do not. So when you multiply, you literally just multiply straight across. So I could just think, since this is multiplication, I can look at this as like one big fraction, this being multiplied by this, and this being multiplied by this. That's literally what's happening. Now, I don't want to actually multiply that denominator like it is. That's insane looking. So if I don't have to, that'd be great. But so I'm going to go ahead and factor what I can, but it just end up all in one big fraction. So when I factor this 49 minus y squared, that's going to be 7 minus y times 7 plus y. and then I multiply that by 48y cubed. In the denominator, when I factor this first one, I have a GCF of 6y. That leaves me with y plus 7. When I factor that trinomial, I can jump to this because a is 1. I have y and y. The signs are going to have to be the same. They're both negative, so what are my numbers? Okay, 7 and 3, good. All right, so then at this point, I'm going to look and see if I can simplify anything. I have a 7 minus y. Do I have a 7 minus y in the denominator I can use? No. I have y minus 7. Are these two the same thing? No. Are these two the same thing? Yes, they're the same thing. These can cancel out. Then I've got this 48. I can reduce the 48 with the 6. 6 goes into 6 once, into 48 8 times. I can cancel this y with one of those. So what I'm left with at this point is 7 minus y times 8y squared over y minus 7 times y minus 3. Okay. Now, I can manipulate this a little bit so that I can reduce more. What could I do in the beginning there? Yes, thank you. What could I do in the numerator so that I could actually reduce these here? I don't need a y. I need y. This is 7 minus y, and this is y minus 7. What can I do with this to make it look like y minus 7? I don't want to add anything. Well, I can't just randomly divide something, though. What do you do? Nothing? What have we been doing? Factoring. Is there something I can factor out? A -1. I can factor out a -1. I can't divide by a -1. I can't randomly multiply by a -1, but I can factor out a -1. It's completely different. So I factor out that negative. That makes this y minus 7 times 8y squared over y minus 7 times y minus 3. So now I can cancel those out, and I am left with negative 8y squared over y minus 3. And that is my answer. Okay. What questions do you have? No, because if I did the same on the bottom, then it would flip it around and make it 7 minus y. Then they wouldn't match anymore. No, that's only if you're trying to multiply by a value of 1. But if you're trying to do something on both sides or whatever. All right. Anything else? All right, so we are going to divide here. So when I divide, do I need a common denominator? No. But I do, if this is a fraction, I want to make this into a fraction. And then my rule for dividing fractions is what? Keep, change, flip. You're multiplying by the reciprocal, right? So this first fraction is going to stay the same, but I'm going to go ahead and factor it as I rewrite it. I can factor out in the numerator a 30c squared. That leaves me with c minus 2 over 3c times, and then I use the reciprocal, so now 1 is my numerator. In the denominator, I can factor out a GCF of 2c, and that leaves me with c squared minus 8c plus 12. Okay, and remember, we're multiplying, so that's like one big fraction, and all this can just be multiplied together, right? So I can go ahead and reduce some. This 3 can reduce with 30 and make it 10. This c can reduce with c squared, so I just have one of those c's left. Then 2 can reduce with the 10 to make it 5. And this c can cancel out that last c we had right there. So in my numerator, all I have left is 5 times c minus 2. In the denominator, I have this trinomial right here. We'll go ahead and factor that. And this would be c and c. The signs are the same. They're both negative. What are my two numbers? 6 and 2. 6 and 2 there. So then these simplify, and I am left with 5 over c minus 6. What questions do you have? Anything? Yes, sir. Where did I get the what? The 6 and the 2. Because I'm factoring this. I need two numbers to multiply to give me 12. Okay. What else got? Anything else? All right. Adding and subtracting. When I'm adding and subtracting fractions besides 4th grade math skills, what else do I have to have? A common denominator. Here I have a common denominator. But sometimes y'all still do weird things with common denominators. You don't actually do anything with the denominator. And you've been talking about common denominators since you were in kindergarten, literally. Think about this. If I said I have 1/4 and I'm going to add it to 2/4, that's going to give me 3/4, right? You didn't do that in kindergarten. But what you did do in kindergarten is you have one teddy bear. I give you 2 more teddy bears. How many teddy bears do you have? 3 teddy bears. So the teddy bears is your common denominator, right? They are things. Think of them that way. You don't actually add and subtract them. So here, when I am subtracting these, you have to remember when you're subtracting, you have to pretend like there's parentheses there. Your denominator is still m squared minus 25. So then I have 9m minus m, which is 8m. And negative 12 minus 28 is what? Negative 40. Right? So then I can factor. In the numerator, I get 8 times m minus 5. This is a difference of squares, so it's m plus 5 times m minus 5. Then I can cancel those out, and I'm left with 8 over m plus 5. What questions do you have? Anything? We good? All right. So we are subtracting here. We do not have a common denominator, so we need to get one. And one way to get a common denominator is just to multiply the two denominators together, which I could do that, but maybe there's a better denominator to have, so I'm going to try first to factor and see what happens. So in the numerator of this one, let's go ahead and try to factor this. So the a is 1, so I can go ahead and jump to these parentheses. This is p, this is p, this is negative, so my signs are opposite. I need two numbers to multiply to give me 51 and subtract to give me 2. So what are your factors of 51 besides 1 and 51? 3 and 17. Okay, so, and those are both prime numbers, so those are the only other factors. Do 3 and 17 subtract to give you 2? No. So can you factor the numerator? Nope. All right, so we can't factor the numerator. I'm just going to rewrite the numerator as p squared plus 2p minus 51. Let's try to factor the denominator. This is p, this is p, this is negative, so the signs are opposite. Two numbers that multiply to give me 27, subtract to give me 6. Positive 3 and negative 9. Okay. So since I got that, and I'm going to subtract 4 over p plus 3, can you see a better option for a common denominator? P plus 3 times p minus 9, that can be my common denominator. I just need to multiply this one by p minus 9 over p minus 9. So when I do that, my common denominator then is p plus 3 times p minus 9. Then I'm just going to rewrite the numerator, the first numerator, p squared plus 2p minus 51 minus, and then I'm going to distribute that 4p minus 36. Looks like that. Okay. So then once again, I'm just going to rewrite my denominator, p plus 3 times p minus 9. So then I have p squared. 2p minus 4p is a negative 2p. Negative 51 minus a negative 36, what's that? What comes next? Negative 15. Negative 51 minus a negative 36. All right, so then my numerator has changed from what it was, so I'm going to try and factor it again. So I have p plus 3 times p minus 9 in the denominator. Then this is p and p. The signs are opposite again. What are my numbers? 3 and 5. And then now I can simplify again. And then I'm left with p minus 5 over p minus 9. And that's my answer. Can I cancel those p's out? No. Any questions at all? All right, let's look at number 6. I'm adding here, do I need a common denominator? Yes, and I don't have one, so I need to get one. And here the easiest one to do would be h minus 2 times h minus 5. So that means this first fraction has to be multiplied by h minus 5 over h minus 5. This one has to be multiplied by h minus 2 over h minus 2. So y'all go ahead and find your common denominators and add those fractions and simplify what you can. Everybody agree with that? Yep. Then at this point we would try to factor again. I can't factor the numerator, I can't factor GCF out, so there's nothing else to cancel out. There's really nothing to actually cancel out. If this was a 5, then I could factor out a 5 and I'd have something to reduce, but I don't, and you won't always, and that's your answer. Okay, we good? Okay, so then complex fractions. These are usually the ones that cause the most anxiety and where the most math is completely made up and makes no sense. So don't do that. There's no reason to. Just because it looks yucky doesn't mean that it's necessarily that difficult. So I have a fraction and a fraction. All that means, this right here just means division. We know how to divide fractions. We don't need a common denominator. We keep the first fraction like it is, the numerator. So while we do this, I'm going to go ahead and factor at the same time. So I'm going to factor out that 5. So this will give me 5 times 3x minus 2 over x minus 8. then I'm going to change my division to multiplication and take the reciprocal of this. So that numerator now becomes the denominator, 3x minus 2, and I'm going to factor my new numerator here. This could be x and x. The signs are the same. They're both negative. What would my numbers be? 8 and 4. Okay. And then remember, we are multiplying. Therefore, this is one big, we can treat it as one big fraction. So I can go ahead right here and reduce this, and reduce this, and then I'm just left with 5 times x minus 4. 5x minus 20 would be fine, but don't do it, because why? It's one more step you have to do. It's another ridiculous mistake you could possibly make and have a brain fart. Just be done with it. Okay, we good? All right, so number 8, we got fractions and fractions again. One of the biggest mistakes that happens here is you try and turn it into multiplication too soon. We cannot flip and multiply right here. Cannot do that. You can't do it until you have just one fraction in the numerator and one fraction in the denominator. So we have to take care of the numerator and denominator separately until we can consolidate that. So here in my numerator, it looks like my common denominator would be v squared, which means I need to multiply this fraction by v over v. So my new numerator will have v squared as the denominator. The numerator would be 4v squared minus 1. Then the denominator, I'm going to make this into a fraction. My common denominator would be 2v, so I'll have 2v over 2v. And that will give me 2v minus 1 over 2v. Can I cancel out those 2v's? No. But now I have one fraction in the numerator, one fraction in the denominator, so now is when I can change it to multiplication. When I rewrite this part, I'm going to go ahead and factor it because this is a difference of squares. So this gives me 2v plus 1 times 2v minus 1 over v squared times 2v in the numerator and 2v minus 1 in the denominator. Then I can start reducing here. This I can cancel out with this. This v I can cancel out with one of those. So that leaves me with 2v plus 1 times 2 over v. And if you put the 2 in the front on the numerator, that's fine too. Doesn't matter. And that's the best I can do. That is my answer. The worst thing you can do on any of this is to get sloppy with your work or start skipping too many steps. That's when you start making stuff up and bad things happen. Okay? We good? What questions do we have? Awesome.